All real cowboys care about dwarf planets. All right, so my name's Bryce Cottom. I'm the principal architect at Spectrum Labs. Now, I'm sure some of you have had some kind of overview of what Spectrum does, but I'm going to go into a little bit more detail because that has a lot to do with what this content is centered around. So at Spectrum Labs, our mission is to become the leaders in natural language understanding in contexts where civility matters. As such, our primary offering right now is detection of pretty toxic behaviors. Some of them are pretty nasty. I think the most severe, child sexual abuse material, CSAM, grooming. It's kind of rewarding to work on something like that. So we consume user-generated code and detect behaviors that the users that produced that content are displaying. So this comes in text or voice. We have a SAS JSON API that our customers call. Everything internally is all gRPC. But we get these messages return inferencing, and our clients will do one of a number of things, including redacting the content, warning a user, educating a user, rewarding a user for good behavior, things like that. So where we get signal from is a few places, but three primarily. There's history, what's been said in the past, metadata, who's saying the thing that's being said, what environment are they saying it in, what time of day. There are some really interesting correlations between behaviors and time of day that we'll examine, and content, what actually is being said. So we use a mixture of solutions to leverage this signal, aspect models like a Bayesian classifier. We are primarily doing embeddings because it's, we need to vectorize the words so that our classifiers can understand it. So here's an example. This is a sexual harassment example. Let's say there's a chat between two users. It's 11 p.m., which happens to be booty call o'clock. And someone says, I want you, a solicitation of some kind in the past. And then the current message is a very negative response from the receiver saying, go away. That continues to happen, especially over history. There's probably sexual harassment going on, or harassment of some kind. A little bit more severe example, in a conversation between two people at about 3 p.m. for obvious reasons, in the history, if we have detected that one of the participants is underage, or has been asked, how old are you, something like that, and they're being asked, is your mom at home? You might have a problem where you need to call the authorities. So we see some of the worst stuff on the internet. All the stuff that's not safe for work, that's our work. Our conversations get really, really colorful. It's interesting. Okay, so what is client specific about these things? Well, let's take the inappropriate sexual activity, for example. It should be pretty easy to define for a children's game. If it mentions sex, sex metaphors, sex acts, it's inappropriate. But on a dating platform, people talk about sex all the time. Sometimes it's inappropriate. Generally, one of the conditions that makes it inappropriate is if there is a trade or barter of some kind. We call that sex working or prostitution, and it's illegal. So dating platforms are generally keen to remove that from their platform. A little bit more subtle example, a threat. I would think all of us could come up with how you would define this message as a threat. Generally, on a social platform, it's any mention of physical harm directed at an individual. Well, what about for a first-person shooter game? Exactly. People are talking about, like, I'm gonna kill you, get your gun, murder him, get that mother, whatever, right? So our classifiers need to be subtle, sensitive to the subtleties of a character being targeted, which is totally fine, and a human being targeted, which is not so fine. All right. So there are a few options that we'll explore. Oh yeah, one thing I wanted to comment on that's I don't think been touched too much, but I just checked our volume. that we're getting in our API is about 7,000 QPS. So it translates to about 30 billion messages per month. And our mean response time is about 12 milliseconds. And in those 12 milliseconds, we run a bunch of classifiers that align to the menu of behaviors that you saw before. The reason that there are so many classifiers is that there are different nuances for given behaviors. And then beyond that, we have different classifiers per client, depending on the nuances of the client. All right, so one way that you can handle these differences between a first-person shooter and a children's game would be to have a distinct classifier per use case. This is the gaming threat classifier. This is the social media classifier for threat. Another one is different confidence thresholds for the same classifier. So an example of that may be that a children's game wants a lower threshold. They want to cast a wider net and see more of the problems, whereas a dating app might have a higher threshold and they just want to see the things that we're really, really sure demonstrate the behavior. We'll dig into details of each of these approaches. You can have more granular classifiers. So you could break down something like prostitution into sexual and barter and wind up ensembling them. And finally, and this is the one that I probably want to drill on the most, because this is where I spend most of my time, where there's a handoff between data science and runtime inferencing, and that is supplemental determination logic that augments your classifier's capabilities. All right, so the first one we'll run through pretty quick, a distinct classifier per use case. So you could have client 123's hate speech and client 234's hate speech. Well, what this generally involves, if you take this approach, and we've currently or in the past used just about all of those approaches. You produce predictions out of your classifier. So client 123 gets predictions they action on or don't action on it, or hopefully they pay attention to the response. And one mechanism for refining that for client 123's specific use case is to get feedback from that client and then add that into the training for iterations that enhance the accuracy of client 123's hate speech model. None of these classifiers are the general purpose, like SageMaker type thing. We do our own embeddings and stuff, so this can get kind of labor intensive if it's not off the shelf type thing. So you would have the same cycle for client 234. Now, you can probably see a number of advantages and disadvantages to this. We'll examine a few of those. But one thing that stands out as, well, I'll start with the advantage, is that you isolate the feedback from client 123 from client 234. So if client 123 says, no, I don't want you to catch records like this, don't flag those. But client 234 says, please flag more of those. You can isolate those. Another is getting improvements back into your baseline. If you have very, very client-specific nuances that you're training on, filtering out the commonalities into the baseline can be kind of a challenge. Sometimes you have to filter the client input. You would think clients would give you high-quality feedback, but a lot of our clients that deal with our technology aren't very technical. And so sometimes we just get some stupid nuance. Like this weird spelling of the F word you missed. You gotta get that. And you're like, all right, but you do have someone with a contract to kill someone else on your platform, right? Okay, so pros, use case isolation. We covered that. The ability to tune without affecting other use cases, and isolating changes between clients. The cons are that the classifier training workflow really needs to be dialed in if you're gonna scale this. So you really need like pipes set up for consuming this feedback from customers, refining it, adding it to a client-specific training set, push button type, retrain all of the hate speech classifiers with their individual paths. That can be difficult to set up. All right, you could have resource consumption. Like this gets out of hand if you have, hundreds of classifiers. So the memory on your memory and CPU on your inferencing infrastructure could be affected. And then getting the feedback into the baseline can be kind of difficult. All right. Yeah, we've touched on some of these, sharing the enhancements. That can be kind of hard. So let's examine different confidence thresholds per client. So this would look something like, this was hate speech if the classifier's confidence was greater than or equal to the client's threshold for hate speech. Our code doesn't look like this. We don't have anything that is like, is it hate speech? We have something like a config that would say for client 123, they have licensed hate speech and threat, and their respective thresholds are 0.759 and 0.625. So, in this approach, there are a few pros. You get to use one classifier. So you're always just enhancing this one classifier. You have pretty straightforward workflow. It's conceptually pretty simple. Everybody's just got their own threshold and then they're happy with that. We'll touch on that in a minute. And the training workflow is not nearly as complicated as a classifier per use case. All right, the cons is that this really only helps you refine recall at the cost of precision. So the second point illustrates that a little bit more. The more confident, the predictions that the classifier is more confident about don't necessarily align to the most severe. As a concrete example of that, profanity would be a decent example. Hell or damn, high confidence, those are profanity. Not nearly as bad as the F-bomb or the C word. So, this requires some kind of config infrastructure and workflow for maintaining these thresholds and config on a per client basis, or at least per use case basis. Enhancements to the classifier need to improve everybody's use case. So if you beef up detection of a nuance of a behavior like hate speech, and it creates tons and tons of cases for the moderators for one of your clients, and the value that you're getting out of your platform is not as good, that can be a tough balance, juggling between those. All right, so there's if you examine the distribution of the confidence of your classifier, for ours, one way of refining or examining the confidence distribution is on the left side, the very low confidence side, you want to have tons of records, inference that say like, yeah, we're really confident this is not hate speech. And on the other end, a bookend, you want a bunch of records that say like, I'm really confident this is hate speech. And then you want like Death Valley between them. So it never starts out that way. So as you refine that distribution and you gravitate towards those centers of your accuracy that show improvement in your classifier, everybody's thresholds have to change. So there are some problems with that. We happen to have multilingual embeddings. We build our own embeddings, and we have language detection that Devanshi created, which is amazing. And we have noticed subtleties on the confidence out of our multilingual classifiers that align to a language. So you may need to have some factor in your inferencing that affects the confidence, might need a different threshold for some other value. So for instance, Korean was a big variable for one of our classifiers versus English. English we could have really dialed in threshold, but Korean we had to be a lot loosey-goosey on that. All right, the more granular classifiers, this one's pretty straightforward. You can break down something like prostitution into barter and sexual. This is particularly interesting when you can reuse one of the granular classifiers. So e-commerce platforms are keen to make sure they get a cut of the transaction that that their platform is facilitating. And so a big problem that they have is people using their platform to find what they want, contacting the seller directly and be like, dude, can I Venmo you? So barter would be very useful for that. Child sexual grooming, similarly. Sexual and underage, you can ensemble together to get some useful signal for child sexual grooming. All right, pros and cons of this. It's especially useful when you can reuse them, as we've covered. It's easier to iterate on a granular signal. Okay, so imagine in supervised learning, you're paying for records to be labeled for prostitution. They get one record that talks about sex. They're like, all right, that's sexual, but it's not prostitution. Another one that talks about barter. They're like, all right, they're talking about a price, but it's not necessarily for a sex act. And then finally a record that's all like, sex act costs this much. Okay, that's probably prostitution. All right, so those variables make labeling for a compound behavior rather expensive. We've found this to also be the case for confidence, for severity. So the more dimensions you add to your labeling, the more expensive it can be. All right, so if you have very narrow behaviors like barter, it's pretty easy for labelers to hone in on yay, nay for that. So it's a little bit more affordable to get labeled. Cons, you can get out of hand. You can start having like the English hate speech, white nationalism classifier. That's probably going to be really expensive to maintain all of those. Pricing and packaging can get kind of complicated with super granular behaviors. If you're exposing the predictions that you have for very granular behaviors, pricing can get kind of out of hand, and then maybe there's black magic and you're just selling the aggregates. Same thing. It can get kind of complicated, and then attribution of your investment to revenue can be difficult. All right, so if you have two classifiers that are working together and ensembling to create a single prediction, there may be dependencies where you need to enhance both in order to maintain the accuracy of the aggregate. So if you enhance sexual a bunch and catch a lot more stuff, you might need to hone in your bartering as well and get it dialed in more in order for prostitution to be to maintain the value that it provides to your customers. All right, you may need to detect dependency requirements. We do this pretty aggressively. So classifiers can talk to other classifiers. We have decision trees that we'll examine next that can reference behaviors that have classifiers that reference another behavior. That can get kind of tricky. So you need to make sure that you're aggressively checking that. And this does have an overhead of a lexicon changes. So if you broaden your definition of what makes something a barter, everything that uses your barter classifier for their aggregate signal will have a ripple effect. And you got to make sure that your lexicon alignment doesn't negatively impact behaviors that are depending upon this classifier. All right, my favorite, supplemental determination logic. Okay, so we have kind of a decision tree. I'm not sure about your inferencing use case, but I find it not very likely that all you do is give a confidence to your customer and they run with it. You probably need to tell them something a little bit more. So for insult, we might want to check the classifier's confidence, or was there a term in the message that was stupid, ugly, or dumb, and it was not sarcastic, and this user's reputation is really high, or this user's reputation is not high, and the language was in one of the licensed languages for the client. Okay, so
sorry, but
yeah.
for the last one, and this is just, I think, helping you make the point, that when you build classifiers, of course you can make a classifier that is all of these together, but then you have to make many of them. So the trick is to make, define the Goldilocks of enough classifiers that you can answer these questions, but not too many, so that you can build those building blocks still. But this is basically kicking the can down the road, meaning that the inference you have to do a lot more work.
Yeah, so actually, thanks for stopping me, because there is another point I wanted to make on this. The things like this tokenless thing, ideally, in an ideal scenario, these are only filling a gap between iterations of your classifier. So in a perfect world, you get feedback from a client on some behavior, you're missing this new racial slur. And you can add that to a list that's dead simple. And the goal would be on your next iteration of that hate speech or insult classifier that you incorporate the terms in the token list. So the token list grows right after you release and then shrinks as you train. Again, this is an ideal scenario. It's very difficult to achieve. So yeah, we can, a lot of these should, the theory behind this should be to just make the adjustments to a classifier easier, because it can be kind of expensive to iterate on a classifier like every day. So, and that, and at least we've found the timeline for labeling is not super quick. So.
How much do you trust your confidence thresholds to stay consistent after the training?
Yeah. So there are, that goes back to one of the cons that I mentioned before with a threshold per, for a single classifier. Yeah, hopefully you're not making massive shifts in your confidence, but you do need to keep upkeep on them. So one of the tasks in a model iteration should be to verify that the confidence thresholds that you're using for decision making in whatever capacity you're leveraging your inferencing is still of value, and it hasn't drifted too much. Great question.
And also probably depends a lot on the type of classifier. Like you can't just change the classifier type to whatever random forest which you use in your network. Somebody has completely forwarded.
Yeah, your approach, your strategy for enhancing your classifier should probably not be super drastic. I can see a workflow where you could anticipate a very drastic change, and you introduce that as a totally different signal while maintaining the old one, and then retire the old one, adopt the new one. A hot swap for something like that's probably high risk. Devanshi.
I just want to add to this point that every time we iterate on the classifier for a behavior, it is usually that we have some new trend related to that behavior. So it's only getting added to the existing things that we have in our training set. So that shouldn't affect the scores or the way the model learns for the previous trends. It just learns the new trends with the old trends. So that doesn't vary the output a lot, but we do have tests in place which do that, regression testing, smoke testing, to make sure that even though the threshold may be a little bit less or lower or higher, it'll still take care of, yes, it should flag.
Other ones?
Yes. Are the updates can be getting done by Spectrum or does it?
Oh, yeah, totally us. Yeah, no, we don't out delegate any of that to the client. We have a pretty robust data science team. They're pretty amazing. Okay. So the points that I told you, I spend a lot of my time at the intersection of data science producing some kind of logic to detect a behavior and us deploying it. So this is close enough representation of some of the tools that we give our data scientists to compose some kind of solution or detection. And the things that I want to point out are that, I guess this maybe goes without saying, but I'm going to say it anyway. We have tons of classifiers, tons of behaviors. We have quite a few. And I'm an engineer. And good engineers are lazy. They want to solve a problem one time. And so I don't want to write, this is the hate speech classifier code that invokes the hate speech classifier. You added a new behavior, bullying? Gotcha. Okay, I'll write code that knows how to call the bullying classifier. That would make me want to stab my eyes out like Oedipus. So we have one, like exactly one. And what I want to explore is how we can make that one classifier invocation mechanism satisfy all of these use cases. One of the ways is this supplementary logic that lets us compose the threshold, what version of a classifier we want to use, what embedding we should be using for that, what kind of pre-processing strategy we want to leverage for this. A lot of levers for people to tune. Also, we have a tokenizing strategy, the embedding that you want to use. Yeah. A number of different things on the config that people can refine. All right. So I want to, in the interest of time, probably examine, I want to talk a little bit more about, all right, our mechanisms for classifiers to describe what input they need. So I've seen in a couple of instances people showing like, model.predict and taking in some array of values. Not all classifiers are going to consume the same signal, right? We have some pretty common ones like the content, what is being said. Almost all of our classifiers consume that in some form, either raw text as character-based bytes or an embedding. But we also have history. How on earth can our classifier find out how many times a given behavior was detected against a given user? Or was this conversation ever about school? Underage signal. Okay, so these areas that we get our signal from are kind of like menu items that our classifiers and our rules can direct us at runtime to go and fetch signal and feed it to the prediction. So we have embedded text, metadata attributes from the message. These usually things like user ID, time of day, user region, declared language, declared gender. That's actually really big for some dating stuff. Okay, contextual metadata from our system and message, like what time did this message hit our server versus how long ago was the user's account created. Big deal for spam. Okay, Bayesian classifiers we leverage a bit, and so the Bayesian approach is you're making some prediction for the current content. You want to know what your previous prediction was, and then have it affect your next prediction. So we need to have a way to go and store those and consume those from classifiers and feed them to them. The reputation of a user, the output from a different classifier, the output from a rule, all these things are options for our data scientists to pull from. All right, so the way that, all right, let's examine the client-specific nuances here when it comes to like metadata attributes. Let's say client 123 is sending you the self-identified ethnicity, the user's gender, and the user's region. Whereas client 234 is sending you the user sign-up date, user recidivism, like how many times have they been punished, and the user's language. All right, so these are different, but they may contain very valuable signal for that particular client. So a couple of options for consuming them, you can say, give me the gender if the client gave it to me, gave it to us. Or compute the difference between the sign-up date and now if you can find the sign-up date, things like that. All right, so we've covered how some classifiers are going to consume different information. So given the different attributes, maybe some of them are useful for threat and others are useful for hate speech. And so essentially I have these two classifiers that want some of the same data but a bunch of different data, and I only want to solve this problem once. Well, one solution is to use something like a model card. So like a deployment descriptor for the classifier that says, that classifier over there, here are its inputs and some metadata about them. Here are the outputs. So this is a perfectly fine approach, but I don't trust it. People are going to iterate on a classifier and forget to update the metadata. Or somebody's going to put the metadata in the wrong place. Or somebody's going to have the input name in the metadata mismatch with the input. So what we decided to do is a self-describing classifier. So inside the graph, there is a naming convention that we follow for input and output that tells the runtime what information the classifier wants to consume and what information it will give back. So this follows some kind of pattern. You can see I'm pulling the embedded text, 2 attributes, and some state. So our domain model kind of aligns to those 3 levels of signal that we can pull. A message has attributes like raw text, clean text, attributes, language. Our current inferencing, kind of interesting, you may have noticed there was an input that asked for the confidence output of a different classifier. Okay, so I'll give an example of how that's useful. So if somebody in an aspect model, let's say bullying, you can build up the abuse that's just below your threshold until it passes some threshold that you say, this person's bullying. After that, if you've worked with Bayesian classifiers much, you need to get that confidence to go back down, and it doesn't happen immediately. So we can have a supplemental signal that says, if this was bullying and there was a threat or profanity, the combination of those two things makes this classifier say, yeah, all right, fine, it's bullying, or maybe not so much. And then the state. So this would be like reputation, prior, shit that's tracked outside the classifier, because of course the classifier can't maintain that kind of state.
Sorry, but if you go up, you do have though found fundamentally different types. I mean, we're talking classifiers here, but at Spectrum we have the message classifiers, we have the conversation classifiers. Are they different? Are they all embedded into this kind of same story? One mechanism to trigger all of them?
Yeah, because they can self-describe. Yeah. So right down there, there's the classifier dictates, hey, when you invoke me, I want the text from the body and I want it embedded. We'll dissect this a little bit.
So just to be clear, and I think I knew it somewhere, but when do you need to check that information? You're not going to check it for every invocation. You're going to check it just on the deploy once, and then you know where everything is, and then you route it just correctly?
Yeah, good question. For performance, absolutely. At startup, we have a list of licensed classifiers that a given client or all our clients have access to, and we go through this routine once as our setup to have essentially, I mean, I'm peeling back a number of layers that I don't have slides for, but if you just trust my description, there is some way to read data from somewhere. And these tell me where to read it from, so I construct a thing that knows how to get that, and then I never need to look at that again, because I'm like, the thing I constructed knows how to go get whatever the hell it said it wanted. So yes, excellent question. It would be rather inefficient to crawl the graph every single time. Especially in TensorFlow, the libraries, we're a JVM shop, the libraries and access that you get to the classifier's graph are verbose. And you can't just say, give me the things that are listed as input. You have to say, give me all the nodes, and then you filter out the name. And then TensorFlow will add extra stuff on the end, and you're like, was that the one that the data scientist wanted me to feed it to, or is this just some bullshit that TensorFlow added? Onyx and PyTorch are a little bit better. And also, TensorFlow 2 has some restrictions on the naming, whereas PyTorch and Onyx seem to be pretty liberal. So this is pretty flexible with those, but depending on what you're leveraging, what toolkit you're leveraging, you may have some limitations. And so in that case, I would say the model card's probably a better choice. Yeah, we have I think in production today, we have PyTorch. I mean, we export PyTorch to Onyx. And so our runtime winds up invoking Onyx, but I can confidently say we have support for it and we've tested it. I'm not sure if we've deployed one for a client as of today. I don't know. Okay. So our domain model, all right, I want to dissect this pattern that we have for our input and output. So the first part just is an indication of this is being input or output. This gets redundant for Onyx, but we kept it in there because it's kind of nice for humans. There's the scope. Where in the domain model are we going to pull the data from? There's the format, how do you want it encoded, and then the identifier for the specific piece of information within that scope that you want read and formatted the way that you asked. Okay. Yeah, that's it. So the way that I think of these tools, the supplemental inferencing and the inputs, are essentially giving a menu to our data scientists to say, these are the places that you can pull signal from. You get to decide what it is, what you want to pull the signal and how much weight you want to give that signal. And I'll just happily give it to you and not write specific code for a given use case. So that's what I want anyway. All right, any questions? Anything I totally butchered? Yeah.
How do you handle optional attributes?
Yeah, not very well. No, I'm kidding. Okay, so one of the mechanisms is, prior is a pretty good example in a Bayesian algorithm. The first time you get a message from a user, you have no prior. You've never made a prediction against them before. And so I should defer to our outstanding data scientists to give the exact names of the concept in a given toolkit for inferencing, but the one that I remember is placeholder with default. So there can be some kind of unknown or default value. One mechanism that we found, if a placeholder with default isn't available, is describing what a default value would be in this format. I don't have an example of that on here, but yeah, if you don't have a value, then give me this value and I know that you don't have it. So that's a mechanism, two mechanisms really that we use for that. Excellent question. Others?
How good is the definition of all these attributes? Is it really hierarchical where it's sort of a simple definition with just a lot of points, or is it just like a huge list? Is it thousands of points? Is it tens of points?
Yeah, okay, so the most verbose that we really get is in the domain, so the second element in this list. And there are a handful, like 5. Actually less than that, I think. And then for a few of those domains, the key, the purple part here, are very well defined, and there aren't very many of them. For instance, information from the content of a message. You can have the raw text, or you can have the embedded text, or you can have the clean text, and that's it. But attributes, whole different world, and okay, so it's probably appropriate to dig into a decision we made early on about attributes. This is a rather nascent space, so not a lot of people have standard attributes. We're defining a number, but clients gave us whatever the hell they wanted to give us. One client gives us player ID, another one gives us user -ID, and those semantically mean the exact same thing. So we have completely unstructured attributes. Whatever the client wants to give us, they can give us. We have some formats for given things like time, region, language, things like that are, if you're gonna give us that in an attribute, then format it thusly, and then we'll be able to parse it. We've gotten to the granularity of even gender and how you would do male, female, non-binary, other, stuff like that. So yeah, we intentionally don't have those defined. They're not spelled out anywhere, really. And the entire purpose was to let data science explore a given data set from a group of clients or a specific client and say, like, I see signal from this obscure attribute, and I don't want to write code for that. So, yeah.
And just curious, is that all in a single data store, or can it spread different locations?
Yeah, the attributes actually come with the message. So there's never a lookup for an attribute. There are lookups for state. So recidivism, for instance, how many times have you detected hate speech from this user? And that may influence your prediction for was this hate speech. That is in a backing data store, and it's not coming in the message. I mean, unless the client tracks it and gives it to us, but they don't.
But you pick it up as you go. You don't get all of their users and store that. You historical record of the ones that you might care about in the future, and the metadata around it.
Well, more specifically, we keep a record of state rather than remembering attributes. There are certain types of attributes that would be maybe too verbose to send every single time, and we're trying to refine those and create a mechanism, standardizing and a mechanism for them to be sent periodically. Yeah, but for the most part, our clients have had no problem giving us metadata that doesn't change across messages, and it's very helpful for us.
Essentially, they just send you a key value, and then you have access to it directly.
That's right.
Hey, Bryce, we have 4 more minutes, maybe 1 or 2 more questions.
Okay. Or 0, maybe. I have time for 0, right? Okay, yeah.
You've got to be 4 more minutes.
I don't understand the math or the science behind this news related item. So the Facebook content moderators have some kind of news, that's the worst job in the world. I've seen a lot of horrible stuff, brand moderators. Do you think the product with such spectrum how does it work with that, that team and that kind of job?
Yeah, excellent question, and we have some blog posts around this. The psychological impact of a moderator is severe, and our goal would be to find things that you can take off their plate. So ideally, we would like moderators to deal with the very borderline cases of like, well, our classifier is kind of sure that this is hate speech, but not totally positive you should make a call. Those things we can actually capture depending on what features from Spectrum the client has leveraged to give us signal back. But ideally, that's where we would rely on humans to just refine the unsure parts. Those bookends for the confidence distribution I was talking about is the more you can gravitate towards those two ends, the less humans need to be there.
Right. So how I'm hearing what I'm hearing is, if they're looking at 10 pieces of content every day, and there are 10, so overall 100 pieces of content, there are 10 employees, 10 person. If they use Spectrum, then they can reduce it to 2 pieces of content per 10 persons, so like 20 in total. So they only have 20 pages. But they still have to see that same content that they see today.
No, the tools they're gonna look at are gonna be not the worst ones.
Yeah.
The most
Which is so that is my point, right? Right now they see normal distribution like the moderate F-bombs are the most common and the gruesome violence is part of it. If we implement Spectrum, they only see the gruesome violence, and Facebook is like, oh, now 2 of my employees can do the job that 10 people do earlier, but these 2 are only going to see the worst cases.
No. Remember, there's a difference between severity and confidence. Yeah, it does not mean the most severe we wouldn't catch. Actually, ideally, the most severe we would have the best answer for. Like, they're giving an address of this exact person and the weapon they're going to use. That's pretty bad, and we can have damn high confidence that that's a threat. So, again, the example that I would bring up for confidence versus severity is swearing. Damn and hell, high confidence, those are swearing, not very severe. So severity and the confidence totally separate, and ideally, we don't want the most severe to land at a moderator's on a moderator's plate. We just want the things that we're not confident enough to automate against. So a lot of this is around automation. Some behaviors are easier to automate, like profanity and offline transactions. Those are a little bit easier. What we've found is the most severe behaviors generally are the least prevalent. And so there is a challenge in curating enough data to train a classifier to be super confident in those, which is kind of a good and a bad thing. You don't want tons and tons of seeds. We've seen some of it, it's demoralizing. People are horrible. All of them? No, not all of them. Okay, we're at time? All right, well, thank you very much.